What's up, YouTube? This is my C++ Minecraft clone. I'll keep it simple. We'll do a summary for everybody that has just started this series. Then I'll tell you what we're going to do during this stream. And at the end of the stream, we'll do a summary what happened during this stream, which will be in about 3 hours. So let's summarize what happened from the previous stream first. So like this is my Minecraft clone. It's made with C++ and Raylib. This is the 360 panoramic view of the actual game. Here we have a simple menu with buttons that you can hover, and we can actually start the game. So let's start with where we left off from the previous stream and then a bigger summary. So from the previous stream, the whole stream we focused on item drops. These are the item drops. They rotate and they go up and down, and look at how they have a drop shadow below them. Here they have a shadow below them, and they also go in a random direction, and they also collide with the world. And basically whatever block we break, we should be getting it, an item drop. We can even do this, even the anvil, like this. Even if we do anvil, we should be getting item drop. Like this, we break anvil, we get item drop, chat. We break endstone, we get item drop. Crafting table, item drop. Obsidian, item drop. We have item drops. This is from the previous stream. But let's summarize in total. So we have clouds. Problem with clouds is that they are not endless. They stop at a certain point here, and they are a single image. They're very simplified. We also here have caves, which use 3D noise generation. Also, we have F5 mode. This is the F5 mode. We have rain. This is the rain. We can hide from the rain. Even if we dig down, we hide from the rain, chat. We hide from the rain. Also, we have dimensions, so we can create an actual nether portal like this, chat. We can create a portal. This is the portal, chat, and we just hit it with the fire. Bam, portal. We should be able to go to the nether. And we're going to the nether, chat. This is the nether. Nether is very simple. It's just like the overworld. Very simple. But it has lava. Also, what else, chat? We have TNT and we have liquids. Look at this, chat. Don't look, chat. Don't look at this. Some of you may be blown away seeing water in the nether. Don't look at this, chat. We also have lava. We have lava, chat, which spreads around like this. Also, when the liquid finds a hole near it, it will prioritize going towards it. That's pretty cool. Also, yeah, we have TNT. We have TNT. We have TNT, chat. Also, let's go back to the overworld so I can show you something else. So, back in the overworld, we also have mobs. These are the mobs, chat. They should start playing sounds at some point, yeah. Now they have sounds, chat. So, we have the cow. We have the pig, we have the chicken. That's pretty cool. We also have creeper. We have the creeper. which doesn't attack the player. He just walks everywhere. The teleportation between dimensions is always in the same spot. When we teleport through portals, it ignores the location. We just had a very harsh deadline, chat, like, and I'm a single developer. Give me some slack, chat. This is your first message, and this is your last message. We will not be seeing him again. Yeah, don't worry about it, chat. We can actually go in subscribers mode, it's fine, chat. We can easily manage chat. Okay, and also chat, let me show you the end dimension. But the bad thing is, in order to have the end dimension, I need to remove the nether. Right? Overworld. Yeah, here. The end. This will give us the end dimension. Yeah, midnight. Okay, so in order to go to the end, we use this poppy flower. We teleport to the end dimension with a poppy flower. Sadly, I didn't have time to do the end portal, but this is how we go to the end dimension. This is how we go to the end dimension, chat. Here we have all of the pillars. The pillars have different height and they have different radius. And here, this is the fountain. This is the fountain, chat. But we don't have the boss. But we can spawn the Enderman, chat. These are like maybe 200 Endermen walking around. Will you add the Ender Dragon? Imagine if we managed to add the Ender Dragon. I feel like it will be impossible. Do speedrun, just find the closest flower. So, did I miss something else from the summary, chat? Did we miss something else from the summary? Yeah, here in the inventory we have a scroll bar. I like this feature a lot. Down below we have the hearts and the hunger, and we can change the amount of hearts we have. And we can pause the game here. We have a pause menu, which doesn't pause the entities, which is a bit of a bummer, but what can you do? And we can go back to game, but we cannot save and we cannot change the render distance. This is just temporarily there. Hey, I'm new here. What's up? What's up? What are we doing right now? I'm doing a summary for everybody that's new here, like for you. I'm doing a summary for people like you. And then we'll focus on a feature. I'll tell you in a minute what we're going to do. And so we can go back to the overworld the same way we came through the poppy flower. And I think it brings back all of the Endermen as well. It brought back all of the Endermen. Yeah, flower portal. Anything else of importance? We have chat here. Hello. Here we have chat, and we can do survival. We can go into survival mode where it's not finished. We don't have the crafting, and Steve doesn't follow the mouse. That's a bit of a bummer. And from the creative inventory, I can show you the crafting table, which we haven't completed. Crafting table is a bit broken. It shows the pause menu, which I have been ignoring for a while. How did animals not get preserved when you went to the end? We just restarted the game, that's why. So the last feature, oh yeah, and we have the animations from the right hand. We have sounds when breaking blocks. We have sounds when walking on grass. which walking on grass sound is pretty quiet. It's difficult to hear. And also we render in the right hand whatever item we're holding. We render it in the right hand, which wasn't easy to do. Chat. Rain and TNT I already showed. Okay, chat. So this was the summary. It's a good enough summary. Now, for this stream, chat, what are we going to focus on during this stream? Well, this is currently my clone in C++ and Relic. Let's compare it with the original Minecraft. And I'll show you what I'm thinking of implementing, chat. This is original Minecraft. And we'll go in creative mode. Chat, do you notice a big difference between the original and my game if we ignore the biomes? Like somewhere up in the sky, chat. Somewhere up in the sky. Somewhere. Yeah, the cloud. Yeah, I was thinking, chat, to do the 3D clouds. What do you think, chat? I was thinking of doing 3D clouds. Try to finish sounds. I don't mind the sounds. Loading where you can see black squares in middle as crosshair. What else? Block rotation. Clouds are fast. 3D clouds should be implemented, and there should be sky color too. Volumetric clouds with subverse scattering. Bro, who do you think I am, man? Like, do you think I can do something complicated like that? Yeah, okay, chat. We're doing the clouds. We're doing the 3D clouds. This is the goal of this stream. We're doing the 3D clouds, chat. At least we'll attempt to do the clouds. After 30 minutes, we'll see where we are. 30-minute timer. We'll do a 30-minute timer. If after 30 minutes we don't have significant progress, we'll switch to something else. So that's it, chat. That's the summary. That's what we're doing. Let's start this. So, like every time, we'll go to Minecraft for reference, and we need to change the version of game we're playing, because I had a different version of Minecraft that had a very useful mod. Are you also gonna fix the clouds? Well, we're doing 3D clouds, so like the answer should be yes. Cloud rendering, what do you mean? Okay, chat. Here, options view. Yeah, it was here, chat. Here, I want this debug mode. Apply. It doesn't show it for the clouds. That's a bit of a bummer. Let's enable 3D clouds. Here, clouds. Fancy. Apply. And I still don't see them, chat. Video settings. Let's remove the shader. Yeah, the shader doesn't allow me to see. What I was trying to do, chat, is I enabled the fancy shader that allowed me to see the wireframe in game. This is extremely helpful. This helped us a lot when we implemented the water. This was extremely helpful. The problem is I wanted to use it for the clouds, and the clouds are not showing. And chat is saying to look at the shader settings. Let's give it a shot, because if we manage to change the shader through settings and are able to use clouds, that will be very useful. Shader pack settings, wireframe, world normal, view position. Yo, I didn't know this had settings. Sky strength. What if we do 1 here? And apply. Nothing changed. What if we do here feet? What's this? View position, what's this? Whoa! What's this, man? Bro, what's this, chat? View position. What's this, chat? This mod looks cool. Do you use the 30 minutes timer for everything doing coding? It might be just on a different render layer. The shader, Z buffer with coordinates. Oh, this is Z buffer with coordinates. This is the depth. Apply. Whoa, this is the depth buffer, chat. Yeah, this is for when like the game how the game calculates if one mesh is in front of the other. It's through the depth buffer. This is interesting, chat. Yo, this is cool, man. What else can we do? World normal. Yo, what? This is the normals. Interesting, chat. Wait, why is there nothing from this side? But here is blue. From this side is blue. From here, nothing. And here, nothing. Bro, this is so useful, man. Negative values, culling, I guess. Interesting, chat. Also, maybe the normal is like 0. Maybe it's 0 the normal, and they're just not using it. What's this? This is a shader, chat. Bro, this is extremely useful, man. You cannot imagine how much time this saves, because usually I use render doc, which allows me to visualize sometimes information like this. But here you can do it a lot faster. This is extremely useful. What else? View normal, what's this? Oh, this is just, this is maybe a different normal type. Light map. A light map. Interesting. Oh, this is for the lighting. And so here it should be a lot darker. Bro, chat. Oh, here we're in the water. These particles are from the water. Interesting. And here the caves. Here maybe again the water. And here some kind of a cave. Yo. Chat, I'll share you what this shader is. Yeah, here. First I had to install this iris mod. Like sodium iris, I don't know, something like that. And here shader packs, I just installed this debug view. That's what it's called, debug view. And in shader pack settings, you can play around with all kinds of useful modes. Yo, this is just like my game, man, without any lighting and ambient occlusion. This is just the texture colors, chat. This is just the texture colors. It's just like the Minecraft clones from YouTube channels. Bro, look at how weird it looks just with the texture colors. Interesting. What else? Wireframe, light map, feed player position. What's this? I don't care about this. World position. I don't care about this. View normal maps. Don't care about this. Test PBR. Test PBR? What's this? What does test PBR mean, chat? Is this like a shader? Place redstone. You mean this? And you want it to be in the albedo. Yeah, this is redstone with just the albedo. just the colors of the physically based rendering. Put on prime sage texture and see what happens, maybe something interesting. That's not a priority. Okay, let's go back to the shader. The problem was I wanted to have the clouds visualized. I wanted to have the clouds. But it seems like they don't allow me to look, because I wanted to implement the 3D clouds. And sadly, I was trying to use this shader that visualizes all of the wireframes. I wanted to use this mod to show me the wireframes of the clouds. But sadly, I don't think we'll be able to do it. Clouds are PNG. Clouds are not a... Wait a minute. Clouds are a PNG extruded into a mesh. Wait a minute. A PNG extruded into a mesh. Wait a minute. Let me do a quick test chat. Let's remove this shader. Let's remove this. I have an idea. Okay, we have the clouds back. We'll do a screenshot chat. We'll do a screenshot and we'll compare the simple clouds with these ones. Okay, and now in options, let's bring back the simple 2D clouds. I want to compare. Apply. No, fast apply. Chat. I think you may be right, chat. You may be right. Let's compare the two screenshots. Like this. Bro, you're right. Literally the same, chat. It's literally the same. The 2D clouds and the 3D clouds. So what? They create the 3D clouds through an image. So how would they extrude it, chat? How would they do the extruding? That's interesting. Average chat IQ 276. Yeah, chat is extremely smart. Let me screenshot who the person suggested it. Are actually made up of cubes, which are pixels of a texture. Who said it, chat? Clouds are PNG, it only extrudes into a mesh. Yeah, this was the W, chat. It was extremely useful. Let's open Excali draw big W, but let me remove all of this stuff. Big W chat. Okay, chat. So from my 200 IQ chat, we found this chat. The 2D clouds and 3D clouds are absolutely the same. Absolutely the same. Also, oh, bro, you're right. Shader. We can use a shader. The most popular shaders are a vertex shader and a fragment shader. The vertex shader can only change, like, you can change the position of a vertex. Like, you can do simple stuff like that. Fragment shader, you can change a color of pixel or like a pixel on the screen. You can change a color. Those are the two most popular shaders, but there are other shaders as well. One of them is the geometry shader and another tessellation shader. Tessellation shader, was it called that? And another is the geometry shader. Chat. I've used the geometry shader before when I created my 10 million TNT project, chat. Yeah. I'll show you guys. Yeah, here, chat. Here, when I did my 10 million TNT project, this project, I used the geometry shader. The geometry shader basically allows you to create additional vertices. You can give it a single point, and as a result, you can create anything you want. The shader from a single point can make it into a triangle, it can make it into triangle strip, it can make it into anything. I sent to the shader the TNT positions, and the geometry shader changed those positions into cubes through the geometry shader. And I wanted to do it from the shader because I wanted to dynamically decide if the point becomes a TNT or it gets destroyed, because the geometry shader can also decide if a point gets destroyed, ignored. And so I'm thinking we can create this chat. We can stick with the simple clouds and send them to a shader, and the shader to add additional vertices, to add them through a shader chat. That's what I'm thinking. That's what I'm thinking, chat. Not really recommended to use geometry shader. Well, honestly, I don't care, chat. Like, it's more fun to do it either way. Like, I honestly don't care. And tessellation shader, chat. I haven't talked about the tessellation shader. I haven't used tessellation shader, but from what I have seen from Learn OpenGL, which is the best place to learn OpenGL, they showed as an example, I think, the terrain generation, chat. Basically, you can have very simplified terrain generation, and with the tessellation shader, it will increase the vertices of the plane, so you can get even more detailed terrain just through the shader. That's where you can use tessellation shader. Like, it adds more detail. And you can, like, the most used example is for terrain. Like, you can notice here how here you have a lot more vertices, but here you have a lot less vertices, chat. Here you have a lot less vertices. Like, this is through the tessellation shader. But I think I'm more confident with the geometry shader. So I personally prefer to use geometry shader, where here, I think this person in this guide, they're sending it point. Here, from a single point, they're creating this house. Look at this, chat. You just set it up here. You're telling the geometry shader, you're receiving points, and I want you to give us a result, triangle strips. Which triangle strips? I'll show you. Usually meshes are rendered just with triangles, but this is a different primitive for drawing. This is a triangle strip, chat. You can just create more faster triangles. With less vertices, you can create triangles. And this is the geometry shader, chat. And here, look at this, chat. They're building a house from a single position in the world. And they just create the new positions. And they do this emit vertex, emit vertex, emit vertex, emit vertex, by giving it new positions. And I think the geometry shader sends them to the vertex shader, or maybe to the fragment shader. I'm not sure what the order is. I haven't used it in a while, in a few months. Let me think about it, chat. So the goal is 3D clouds. The goal is 3D clouds. And one viewer from chat suggested to extrude the 2D clouds into 3D clouds. So to reuse what we already have. And I got an idea to use the geometry shader to accomplish this. Should we try it, chat? Should we try it? I'm thinking if we should try it. what are we going to send it, chat? Let me think about it. We can do something else as well, chat. Chat, I have a different idea. We can have two geometry shaders. A simple one where it creates just this, chat, where we just give points to the geometry shader. We just give it points and it creates the simple planes for each pixel, for each point. It will create this simple plane. And then a second geometry shader that does the same thing, but more complicated. It will create cubes instead. It will be, so we'll have two geometry shaders. Why you can't use normal maps? What do you mean? Here, let me print this, chat. Let me print this and go in Excalidraw. I'll show you what I mean here. So we can send here this position, this position, this position, here. All of these red dots will be separate positions, chat. And the tessellation shader, initially, the simple version, will just create this shape through the point. So just like the tutorial, chat, we'll give it points, and as a result, it will just create a single plane. It will be even simpler than this. It will be even simpler, chat. This will be for the 2D version. This will be for the 2D version. And now for the 3D version, it will be almost the same thing. Almost the same, a slight difference. There will be a slight difference on the output. The slide here, it will be the same for the tessellation shader. The second version, the more complicated version, will be sending it again points. These points will be sending it. All of these points. But this time, instead of creating a simple plane, it will be creating a more complicated cube shape. More complicated cube shape. That's my idea. That's my idea, chat. But the problem is I haven't used geometry shaders, chat, in a while. I've forgotten some of how to use it. I've forgotten. I'm a bit rusty on geometry shaders, and the other problem is we're using Creylip. When I used geometry shaders for blowing up 10 million TNT, I did it in pure OpenGL. But now we're using Raylip, which does things a bit differently, and we'll see. We'll test it out. It's worth it to try it. We'll see what happens, chat. So normal maps at 3D clouds is just texture, and when you get close, the cloud actually generates 3D models based on the texture. Since player won't always see. You can try it in your own project. For me, it's more fun to do the geometry shader. I do what's fun for me. If I don't do what's fun for me, the streams would not be able to continue. Okay, chat, let's do it. Let me sit down. And let me drink some water. Why were you standing up? Because when you spend all of your day every day on the computer, you have back pain, but standing desk makes it possible to continue working on the computer. It was a game changer when I bought a standing desk. That's one of my best. If I had to choose between an office chair and a standing desk, I would pick a standing desk. Like for me personally. For others, maybe better to pick an office chair. Like I would pick a cheap office chair, like this one is very cheap. This is very cheap office chair. That's a very cheap office chair, but the standing desk is more expensive. Okay, chat. The 30-minute timer, will be increasing it. I'm willing to invest 1 hour into this. I'm willing to invest 1 hour. Okay, chat. We're giving 3D Clouds 1 hour, and I need to change the stream title. Stream title, 3D Clouds, like this. And also, where is the game? Here is the game. Like this. These are the current clouds. We'll screenshot them just to change the thumbnail, so everybody knows who's clicking what they're going to get during this stream. Here is the new thumbnail. Select, save, and that's it. What do you currently, the way I do the clouds is very simple. It's just a single texture, so I can even show you the end of it. This is the end of it, chat. This is a single texture, all of this, where it's actually Perle noise. It's Perle noise, but through a shader, I'm changing it into the clouds format. Through a shader, like Perle noise values are between -1 and 1. So it's like grayscale color, if you have seen Perle noise texture. Most of you have seen it. This is a Perle noise texture. These are my clouds, chat. These are my clouds. This Perle noise texture, but I'm putting it through a shader where, using a fragment shader, I'm changing it so that I can even show you the fragment shader. This is the current implementation. Sky, clouds, fragment shader. Yeah, here, chat. If the value is below 0.5, I discard it. This way, I get these empty spots. Else, I just put it to be the white color with a lower opacity, with a lower alpha, and that's it. That's it, chat. And that's how I convert this Perle noise texture into these clouds. This was my first attempt. This was my first attempt, and they don't even move. Minecraft just uses really big preset image and scans through it. We can do the same, chat. We can do the same. We can actually try and find it. And actually, we got another W. Thank you, man. Let me save W. Thank you. Yeah, Minecraft just uses really big preset image and scans through it. Let's find the image, chat. Let's find the image. Where is the image? I need to find the resource pack I'm using. It's with all of the default Minecraft textures and assets. Yeah, here. And so in textures, maybe in sprites, or where clouds. Let's just search clouds. Yeah, this is it, clouds. And let's open it up in Aspirite just to look at it. So yo, interesting. So these are the Minecraft clouds. Yo, thank you. Don't it scroll in only Z axis? How are we going to go through it? It's 256 by 256. We can... How are we going to do this, chat? And these are just single pixels. Each cloud is a single pixel. Oh, I added a cloud. Yo, chat, we can add our own cloud. We can add our own cloud, chat. Yo, what's up, Dimitri? I haven't seen you in a while, I think. Okay, add a smile. A smile cloud. Will we be able to see the smile cloud, chat? Okay, we're adding a simple smile. And let's save it. The creepy face. If hopefully at the end of the stream we'll be able to find this smile. You might have trouble finding that cloud. Yeah, maybe. How are we going to go through these clouds? Well, how big is a single cloud? How big is a single cloud, chat? This cloud, how big is this? This is a single pixel in the texture. How big is this cloud? How big is this? In blocks, I mean in blocks, chat. Chat, can I easily create a tower from down the game to up here? Can I easily, oh, maybe to find a mountain. I want to place blocks up in the clouds so I can measure them. Or can I lower the clouds to be down below? F3 plus G. Oh, F3 plus G. So this is 16 by 16, chat. This is a single chunk. And how big is this? I want a single cloud, this one there. I want a single cloud, this one, chat. How big is this cloud? How big is this? 1, 2, 1, 2, 3, 4. I think 4. 1, 2, 3, 4. No, 5. No, 6. Is it 6 by 6? Oh, Tick Freeze, you're a genius. Yo, Tick Freeze, yeah. But we need to step it. Tick step. 5. 50. 100. $100 again. Maybe, hopefully it's not too much. Okay. 10. 50. Oh, almost, chat. So how much is this? This is 1, 2, 3, 4, 5, 6 blocks. And here 1, 2, 3, 4, 5, 6 blocks. 6 by 6. It's 6, bro. Yeah, okay, so it's 6 by 6, chat. Okay. One cloud is 6 by 6. So here, this image is 256 by 256. And in game world size, 256 will be times 6. So this is 1000. This is 1500 360. 1536 blocks by 1000, like 1500 by 1500 blocks. 12 by 12 in blocks, not 6 by 6. We can easily test it out. Once we fall down on the ground, we can easily test it out. Here. Oh, yeah, 12 by 12. It's 12 by 12. I was thinking this whole thing is one block. It's 2 blocks. Yeah, 1, 2, 3, 4, 5, 6. So this is a single cloud? Bro. Really? Yeah, 1, 2, 3, 4, 5, 6, 7, 8. Oh yeah, it's times 2 because this is 16 by 16 and these ones are 8, and when you multiply them by 2 you get 16. Yeah, so it's 12 by 12. No, this is Minecraft, chat. This is Minecraft. So actually, how many blocks there? It's 3000 by 3000 blocks, the texture. This texture is 3000 by 3000 blocks. Interesting. Oh, the area changes. Sometimes it's 8 by 8. Interesting. Okay, chat. So let me think about this, chat. Let me think about this. So let me think about this. And what are we going to do with this information? How are we going to handle this? Let me think about it. Let me think about it. We need to load the texture. Let's do that. Let's keep it simple. Let's load the texture in game. Let's keep it simple. Let's not overly complicate it. Because we don't have that much time. We have 47 minutes. Let's speedrun this. Textures, let's copy the clouds. This is the clouds. Let's load the texture. Let's load the texture. And chat, this is the last stream. Saturday and Sunday is no stream, I think. That's the plan. So next stream will be Monday. Next stream will be Monday, just so you know. Okay, let's load the texture. Texture here. Let's load it. Clouds. Yeah, the clouds. Clouds like this. Clouds. Okay, we're loading the texture. What now, chat? We're loading the texture in game. What's the next step? We need to read through the values. We need to go through the texture, or there's an alternative. We don't need to read through it. It's actually very simple. We can just send it as a uniform sampler 2D to the shader. Shaders can accept images, textures. Shaders can do that. Yeah, here, look at this. Uniform, sampler 2D, texture 0. We can do that, chat. We can send it here. We'll just create like this uniform, sampler 2D, and this will be the clouds, like this. And we'll have access to all of the pixels. But what are we going to do with the positioning? if we're going to do everything, if we're doing everything through the shader, this is a shader, a chat. A shader is a program that runs on the GPU. And our game runs on the CPU. All of our data is in the CPU. The GPU has no idea of what's happening in the game. So the clouds, what do the clouds need, chat? Let's save this position temporarily. F3 and C. Like this. So we can come back easily. What did I do, chat? Okay. So what do the clouds need, chat? You'd have to pass position to the shader. Which position do I need to pass? Which position do I need to pass? We can always render the clouds temporarily. Yeah. Let's do it very simple. Ask AI, you are gone. Is this your first message? This is not your first message. Okay, I will not. Okay. I'll just do 60 seconds timeout. That was inappropriate. Let me think about it, chat. Yeah, let's simplify it. What's the Discord? I would have to look for the link, and we cannot do that right now. Let's create a shader, chat. Let's create a shader. And let me look up learn OpenGL shaders. What's the order of the shaders? There was an image that displayed this. Yesterday you had 110 viewers. Our best numbers for the streams were 194. That's the most viewers we've had, chat. 194. But I don't remember when exactly that was. I think it was when we were doing a polishing stream. When we did a polishing stream, maybe. And it was on a Friday, I think. That's the only thing I remember. Oh, here, this is it, chat. This is it. This is the order of the shaders. So the vertex shader is always the first one. Then is the geometry shader. And then is the fragment shader. Interesting. I want a geometry shader. Geometry shader relief. When are you going to do the next polishing stream? Well, the previous one was a polishing stream, but the problem was that we spent the whole time with doing the item drops. How to load geometry shaders? Yeah, how to do geometry shaders. How to edit source code. Basically every function such as load shader from memory, etc. Just copy it and paste it in the vertex shader code and change it to geometry shader. Oh, don't tell me Relief doesn't support geometry shaders and we have to change the Relief source code. That will be a bit of a problem. It will be a bit of a problem, chat. Oh, wait a minute. Yeah. The way you create shaders in Relief is through the load shaders function. So let's go back to the game layer. Here, load shaders. And if we do here load shader, and here it expects a vertex shader and a fragment shader. It expects a vertex and a fragment shader. It doesn't expect geometry shader. Load shader. Let's find the source code and let's close the game actually. So it's easier to work. What happened? I'm searching for load shader. Load shader. I'm searching for the implementation of the function. And in the file, I'll search for the geometry shader. If it's possible to load geometry shader. It will be very interesting. Project source code. Here it is, chat. Load shader. But this is just the API. Yeah, this is it, chat. Load shader. This is it. I thank Phoenix for leading me here. Yeah, but Phoenix did a video like 8 months ago. What do you mean? You're saying the video from 8 months ago is leading you here. That's a long time ago. Yeah, chat. This function that Relic uses for loading shaders, it just accepts a vertex shader and a fragment shader. And here, load shader from memory. Load shader program. Sure. Is there somewhere here something about geometry shader? Let's search it up, chat. How are we going to look for it? Geometry. Nothing. Vertex. Fragment. Yeah, there is vertex shader here. There is fragment shader in Relic core, but there is nothing about geometry. Nothing about geometry. Bro, is geometry shader not accepted? Relic. I just realized the reason I started watching you was because Phoenix made a video on your project or something like that. Yeah, but that was a long time ago, chat. Is there a geometry shader for Relic? If not, that would be a big issue. Because our whole idea relies on using geometry shader. Are they that uncommon, chat? That Relic doesn't support it? Because this guy, this is the only mention of geometry shaders in Relic, and this guy says he had to edit the source code a bit. So in load shader, he needs to add support for geometry. Load shader from memory, he needs to add support for geometry, where he just pastes the vertex shader code and changes it to geometry shader. Let me think about it. Relic. Let's look at the Relic Reddit and search for geometry shader. Let's search in the Relic. Geometry shader. Do they mention it here? How do I load the geometry shaders? Oh, it's the same post. Bro, nobody cares about geometry shaders. That's a SC, bro. We got a fan chat. That's a bit of a bummer. Compute. Okay, how do they do compute shaders? Compute shaders are popular. How do they do compute shaders? Shader language is a pain. Lots of mathematics. Don't use Relic, use Godot. Bro, look at how many thumbs down. They're fully working compute shaders. Oh, is there geometry shader in Godot? Does Godot support geometry? Why is there no geometry shader supporting Godot? Interesting. Not even Godot uses geometry shaders. Godot didn't choose to implement support for geometry shaders. Why do they avoid it? If you really need them, you can rebase and recompile the engine. This proposal has no way to realize. Geometry shaders are being deprecated in modern API versions. Oh, they're deprecating geometry shaders. Interesting. They're inefficient and can be better replaced with compute. Interesting. Geometry shaders are not supported in modern hardware. They remain there for compatibility. Godot uses OpenGL ES, which does not support them. They will not. All geometry shaders don't work on mobile. There is not high demand for the feature. Oh, so we need an alternative. Oh, we need an alternative, chat. We need an alternative. Damn. I'm bummed out, chat. That disappointed me a lot. Damn. Can we use then regular shaders? Can we use regular? Probably not. What about compute shaders? Compute shaders? Can we use compute? Compute will compute shaders help us out? I've used compute shaders, but I've used them for GPU located memory, SSBO. Some of you guys may not know what SSBO is, but that's like you can basically use it to store information on the GPU. If you go in the task manager and you go in your GPU, you'll see the GPU has memory, chat. My GPU, I think, has 8 gigabytes of memory. I can use this memory with SSBOs in the shader. And basically, compute shaders allow me to work with the data there. And I used that, chat, for the 10 million TNT. I used compute shaders, chat. I use compute shaders where basically you just execute code on the GPU. So, can we use compute shaders? Can we use compute? We could. Let me think about it. Can we use compute shader? We could give the image to a compute shader and have the shader do calculations like to what would it calculate, chat? What would we need to calculate? Where with a single point to create all of the other points and just to directly send them out to a shader to directly draw them. Is that possible? Yeah, it's technically possible. It's technically possible with a compute shader where in an SSBO we can store all of the information. And with a vertex and fragment shader, you don't need, in a vertex and fragment shader, you do not need to use it in the regular way. You can use it a bit different, chat. Here in the vertex shader, you can notice how you have all of these variables that it accepts on a draw call. You can do it differently. You can ignore all of these attributes that the shader receives on a draw call. You can remove them and you can use something else. You can use the ID of the current vertex and you can go through values from an SSBO that is calculated through a compute shader. Like we can technically use a compute shader, but that's for optimizations. And that would be annoying to set up. So let's just do it the regular way, chat. Let's just do it the naive and simple approach. We'll just do the calculations in the CPU. We'll just do it on the CPU and use vertex and fragment shader and not overly complicated, chat. I'm just a bit bummed out. They require compiling Crelip with OpenGL. Yeah, I'm a bit bummed out, chat, that we cannot use geometry shader. We'll do it on the CPU. I'm a bit bummed out. I didn't know that geometry shaders are avoided. I didn't know that. You make Petsa shaders, you can make it open source. We've been exploring the game's features and then dove into making 3D clouds. Hit a snag when we found Relic can do geometry shaders, so we're figuring out the next move. Or can use compute shaders and don't support macro. No, we're not doing compute shaders. I don't want to overly complicate it, chat. We're doing clouds, chat. It's not that deep. And we're 1 hour in. I'm getting flashbacks from when we did the settings, when we attempted the settings, and after 1 hour we had 0 progress. And currently we're in the same situation. 1 hour has passed and we just yapped the whole time. We didn't achieve anything, chat. We just yapped around for 1 hour. We have 2 hours left, chat. We have 2 hours left. We'll just go over the texture. We'll go over this texture, chat. These are the Minecraft clouds. We'll go over the texture and what are you going to do? You might be able to do ray marching to get them to be 3D. I don't know what ray marching is and I'm not interested in that. Let me think about it, chat. 256. How much can we divide it, chat? 256 divided by 16. Oh, 16 by 16. So if we do, chat, if we do, let's do a grid. I think this grid is actually 16 by 16. Yeah, 16 by 16. So we can do, and 16 by 12, 192 by 192 blocks. How big is a Minecraft world, chat? Let's say it's 20 chunks by 20 chunks. 20 chunks by 20 chunks, and let's say each chunk is 16 by 16. No, let's just focus on one axis. 20 chunks on one axis, and each chunk has 16 blocks on the same axis. So we want 320, for example. And here we get 192. It's fine. It's fine. Yeah, we can do a region of 16 by 16. Let's focus on this region because one cloud pixel is in the real world. How much was it? It was 12 by 12. If each chunk is 19 by 19 blocks, then each chunk is 16 by 16. Don't forget to make it so if you can't see it, you wouldn't render that thing. That's first I'm calling. Actual intelligence also requires water to survive. You're a smart one. I'm happy that how this project became 12. Let me think about it, chat. Yeah, we'll focus on this region. We'll focus on this little region. We'll draw just this, and we'll go over every pixel. We'll go over every pixel. Let me think about it. Actually, wait a minute. Wait a minute. Wait just a minute. Wait a minute. Let me think about it. I could just use a regular plane and increase the vertices count. So I could, but I don't know how to transition to the 3D version because we saw in the beginning of the stream that the 2D version and 3D version are the same. If I do one big plane and just increase the vertices count, just so we have a one mesh for each pixel of the clouds, I will not be able to improve it for the 3D version. And the goal is to have 3D clouds. So let me think about it. Yeah, I think we just need to go over each pixel of the photo. Each pixel of the texture in the CPU. All pixels in the texture are cubes in the game. Yeah, we know that, chat. How to go through each pixel in Relief, chat. How to go through each pixel. We have loaded the image. We've loaded it as a texture. Here, clouds. We loaded it as a texture. We can load it as an image as well. Load image. We can load it and here use the same path. We can use the same path here, chat. We can load it as an image. We can load it as a texture as well. Maybe with the image will be easier to go through the pixels. Bro, we have 24 minutes. That's a big bummer, chat. Raylip. Cheat sheet. Image. Where are the images? Images. Here, images. We can load an image. Load image raw. What's this? Load image from raw file format. Animation from memory. From texture. Interesting. Export image. Export image as code. We don't care about that. Generate image color. We don't care about the generators. We don't care about that. Image copy. Image from image. Image from channel. Yeah, here we could isolate just the red, green, or blue. Image text. Oh no, let's look at this, chat. Image from channel. And we'll just see how they go through the pixels and we'll copy paste it. Yeah. That's the plus side of Relief. Image from channel. How do they iterate? And we can also look at image from image. Let's look at image from image here. This is how they iterate. Oh, they just do a meme copy. They copy the data. No, I don't care about this. Let's do the image from channel. How do they iterate over them? They iterate over the pixels in an overly complicated way. They do it in an overly complicated way. Because images have different file formats. We can potentially look at which case our image falls into and just copy paste that part. Just copy paste that part. What arguments do we give it? An image and a channel we select. Interesting. We need something like this so that we can go over each individual pixel. But I'm not a fan. Chat. I'm not a fan of doing it this way. I wanted to do the clouds because of the idea of handling them in shaders. In shaders, going through each pixel is very simple. Through shaders, very simple. And now that we cannot do it through shaders, I'm not a fan of doing the clouds. Should we change to a different feature? That's what I'm thinking. Should we switch? If we decide to switch to a different feature, because I would have to think more on the clouds off stream. Maybe it will be best to switch to something else. If we decide to switch to something else, What would that be? We could do fluids. We have a lot of options for something else to do. Notepad here. We had a lot of ideas from yesterday. Make clouds endless, have 3D clouds. We gave this idea an hour and a half almost. Let's say 1 hour. We gave this idea 1 hour and 15 minutes. But I'm not happy with the direction of where we're going. We can switch. I'm happy with switching. Dev screen, drop items on dev, item mesh generation. Item mesh generation, also I don't want to do it because it has the same problem as the clouds. Iterating through the image pixels. It's annoying. I don't want to do it. We can do something else. Particles are grayscale. Leaves decay on trees. Okay, let's do these two. And item drops to finish the item drops. Yeah, let's do these three. I'll change the stream. Polishing stream. Polishing. Polishing game. Chat, we're doing something called a pro gamer move. We're doing a switch. We're doing a switch, chat. Let me see. These are the current item drops. And these are this is the problem with the particles. And this is the problem with the leaves. If we break this, the leaves stay the same. Let's do the leaves. I know how to do the leaves. Let's do the leaf decay, chat. The leaves stay like this forever. Let's do a leaf decay. Let's do a leaf decay. Because we've already done something like that for the farming. For the farming, we've done something like that, where the plant will grow, depending on it will be, there's a random chance this block will be hit. And if this block is hit and the environment is well, like you have water, if the environment is well, this will grow. And we'll have the same logic for the leaves. If this leaf is hit, and if it's, and here you don't have the locks here, it's not connected to a lock, it will decay. And this will decay. And if this is hit, it decays. Let's do this, chat. This is extremely important because in the Java clone, when I played my Java clone, you had everywhere trees like this. Because the player chops down a lot of trees. And the whole plane will be filled with this. This is extremely annoying. Let's fix this. Let's fix this, chat. Let's fix this. Let's go to the tick system. Where is the tick system? Layers. And let's remove the timer. Let's remove it. We don't want it. Why is everybody shouting? Your Minecraft clone is so realistic. I thought it was real one. Add glass. We have glass. Even if you want to play. Let me think about this. What were you doing? I forgot. Yeah, the leaf decay. Let's do the leaves decay. Let's do the leaves decay. Let's go in the tick system. So we have world on tick. Draw rain, etc. On tick callback, what's this? Tick system update blocks. Where was the code where we handled the farming? Let's try to find it where we handled the farming. We'll serve, yeah, farmland and the wheat. Generate mesh on update. Also, it's an on update call. In here, on update, the wheat. So we can do it the on update then. We can do it the on update. But that's a problem if we do it on update. Because in Minecraft, Let's unfreeze, tick unfreeze. In Minecraft, when you destroy a block, it calls the onUpdate automatically. It needs to be a different function. It doesn't have, it needs to be a different function for the leaf decay. It needs to be a different function. I don't want it to be onUpdate. Here, do we call on the update here? On update. Oh, this is where we do it. Yeah, we pick a random position and we call on update for the block. We can change it to be not on update, but to be like on tick update, something like that. But we'll need to make a change here. This on update to be on tick update. Here, on tick update. On tick update. On tick update. And this on tick update. And in the world class, where was it? Yeah, here we'll call on tick update like this. So for the leaves, where the, oh, do we have a class for the leaves? Have you implemented a JSON block updates on placing and breaking? I have not, but we have it in the notepad for something to do. How come the movement doesn't feel so smooth? Give me some Slack chat. Did you get Hilt working? Hilt is almost working. Make the clouds surrender like chunks. So that was for the clouds. Will this game be free? Bro, what are you on about? Help the chat. Bro, chat, what are you talking about? I'm not releasing this. I cannot release it. Because Mojang will be angry. Because why would somebody buy Minecraft when they can freely download my project? And I'm using Minecraft resources. I need to do it different. That will be bad from me. What are we doing? I forgot, chat. Yeah, the leaf decay. Let's do the leaves decay. Where are the leaves? Leaves, here they are. Here we'll do on void on tick update position details override. And let's implement this. How will the logic be for the leaf decay? For the leaf decay, it will be a simple pathfinding algorithm, a breadth first search. For pathfinding, you have two basics, depth first search or breadth first search. We can do either of two actually, and we will go through the neighbors. We'll go through the neighbors and we'll check if they're leaves as well, if they're leaves. If the neighbors are leaves, we'll continue searching. We'll continue searching. If we find a lock connected to leaves, it will stay. So even if it's like this, the leaves will stay. What if it's like this? Do the leaves decay? If there is a single lock, if there is a single lock, do the leaves stay? Chat. Oh yeah, so maybe this is the logic. Look at how this tree has a single lock and they continue to stay. Oh, this is interesting, chat. Let's look at this situation. Look at how here a lock is connected here. Let's remove the one here and let's see if they decay. Let's see if they decay when they're connected here. And let's remove the connection from these leaves. Let's see if they decay. This will be interesting. Oh, they decay. Interesting. They start decaying, chat. Yeah, they do. There is a max radius from the lock for leaf decay. What do you mean there's a max radius? Oh, let's increase the tick speed, tick rate. 50. How much is the maximum? Let's do 1000. No. Tick rate 20. It was something else, chat. Time set day. It was the random. What was it called, chat? How to increase the random tick speed? Game rule. Random tick speed 1000. Yeah, this thing, chat. Oh, there's a radius. Oh, I get it, chat. I get it. I get what you mean. For the search algorithm, this leaf has a radius, let's say a 5 by 5 blocks. And it will start searching for a lock. And when it reaches here, it's too far off and it will stop searching. Also, we can do a distance from where we started. Interesting, chat. Yeah, we can do something like that. Why did they stop decaying? Oh, because I placed them, maybe. Maybe because I placed these ones. Oh, leaves that are placed by me. Is there a difference in the block state? Persistent equals true. Oh, and persistent equals false. I don't have that block state. And distance, it has a distance, chat. What? It has a distance in the block state. I didn't know that. What's the distance value, chat? What does the distance do? Let's find the simple tree. Check mod count panoptic. Panoptic modern. What panoptic? What's this? Bro, what's this, chat? Open main inspector. What's this, chat? 50,000 views. Inspector mod for Minecraft. What's this? What? Yo. Who sent that? Who was it, chat? Yeah, it was this guy, Ray. Ray, my bro, Ray, thank you. This looks extremely useful. Thank you, man. Let's actually download it. Why not? What's the compatibility? 26.1.2 Fabric. Let's actually use it, chat. Let's actually use it. So 26.1.2. 26.1.2. So here we can use it. Edit. Mods. Download. Panoptic. I cannot find it. Client site inspection tool. 700 downloads. Why is it just 700 downloads, chat? That's too little, man. Stream starts to buffer. Stream should be fine. Yeah, stream health, healthy. Stream is healthy, chat. Where is chat? Okay, let's continue with the leaves, chat. Let's continue with the leaves. Let's continue with the leaves. Okay, let's do whatever implementation first we can think of, so we can move on, chat. So for the leaves, we'll start a search algorithm. We'll do a queue. We'll do a queue of position details, nodes. For the nodes, we can push the current position. And there is one thing I want to check, chat, is the distance, the block state of the leaves. I want to look at, there was a distance value, chat. What's that? Yeah, here you can notice there's a distance of 4. Here there's a distance of 1. Oh, a distance from the lock itself. This is distance from the lock itself. And this is distance 2. Oh, that's a distance from the lock. For fabric use 121.1. Yeah, Ray, I saw it. It's fine, man. I'll look it into. But the mod has very few downloads. That's I don't get why it has so few downloads, chat. We have a problem with the trees. Here they have a distance saved in the block state. We don't do that in my game, chat. That's a bit of a bummer. So when is the distance used? When is the distance used? Okay, chat, we'll figure something out. It's very new, I told you about, because I thought you would be from the first ones to use it and give your thoughts about it. I'll think about it. But I don't want to download new mods, because anybody can post a mod. Literally anybody can post. So we'll do a simple BFS, which is just, we'll search from the current leaf. We're doing leaf decay. Which basically, if you remove the locks here, the leaves will start decaying. Do they start decaying once we remove all of them? They start decaying. They continue to stay. Oh, do you see how fast they got removed? Okay, chat. So how are we going to do that logic? Well, a random block is picked every tick from probably from every subchunk, maybe. Yeah, I think from every subchunk. Every tick from every subchunk, we pick a random block. If it turns out to be a leaf, we'll do a search algorithm for a lock with a limit of some kind of a distance. Of maybe of a distance of 20 blocks maybe, or like 5 blocks maybe distance. Here we'll do static const integer distance limit, let's say of 5 blocks maybe, so that we don't search for forever, because a lot of leaves could get connected. And so here we'll do while the queue is not empty. While the queue is not empty, we'll get the current node. We'll get the current node and we'll add the neighbors. we'll add a neighbor, so nodes push. We'll push node get. We'll get the down neighbor and all of the other ones. We'll get the up neighbor, we'll get the north, we'll get the south, we'll get the east, we'll get the west, and that's it. And for all of them, we'll first check if this is a leaf block. And all of this is just to decide for if we should remove it or not. Okay, so here we can do ID current. Let me think about it. A boolean should remove leaf. If we should remove it by default, we are not going to remove it. So let's say it's false. Let's say it's false. And what now? And what now? And here, while we're going through the neighbors of the leaves, we'll do a check. We want the current node ID block type. We can do node ID equals node get block type. So if the node ID equals oak lock, but we have spruce locks as well. That's a bit of a problem. But we'll chat is chaos. We can easily solve chat. We can easily solve chat. Chat, don't worry. We can easily solve it. I have a lot of options for chat. Done. Chat, how's this? How's this, chat? Okay, let's lock in. Will you make it so only naturally generated leaves decay? For now, every leaf will decay. We'll need to have a block state for leaves if it's persistent or not. And when a user places a leaf, the persistent boolean will be true, so that the onTick update doesn't remove it. Okay, so if it's a lock, let's say by default, we should remove it. By default, we should remove the leaf. But if we manage to find a lock, should remove equals false. It will equal false. Yeah, and here we'll do if we should remove the leaf, we'll do position details set block type. Is there set block type? Position details, right? Position details. What's the problem? Block origin, get block type. Why am I not getting all of the possibilities? We have a function for position details, which is set block type. Yes, set block type. Why cannot use it? Position details set block type. Yeah. And here to be air when we remove it. Oh, because we're in a const maybe. Oh, const. Yeah, because it was const. How many lines of code? I have no idea. And here we want to travel. Oh, what's the problem here? Oh, wait a minute. The onTick update function requires here to be a const. Interesting. here to be const. But then when it's const, I cannot change it here, but we can change it here. Set block type. Can we do this to be const? Can we? Set block type. Oh, but when we get subchunk and we set block type, it cannot be const because we're changing a block. We cannot make it const. That's a bit of a problem. We can do something else. We can do world set. Oh, we cannot chat. That's a big problem. We need to change it. We need to change this chat. Here, on tick update. It's not const by default. It's not const. Yeah, okay, it's fine. It's fine, chat, it's fine. Yeah, set block type to air. But here we want to travel only when the node is leave, when it's a leave. So if node, if node ID is, how should I let's do it here. If the, and here we break, here we break, but here if the node ID here is not leaves, if it's not leaves, but here is only oak leaves. We have spruce leaves as well, but what can we do? Okay, we'll do it if it's equal, and we'll go over the neighbors. Yeah, we're traveling only through leaves, chat. Only through leaves we're traveling. Yeah, this should be a chat. We should have leave decay. We should have leave decay, chat. We should have leave decay. Let's test it for. Oh, we don't have a limit of a distance. We don't have limit from the distance. We'll just have an integer current distance equals 0. We will need a different node that saves the distance. We will need a different node to not be just the positions, but to save the current distance from the source. Yeah, in order to calculate all of this. Yeah, because we need a limit of a distance, chat. We cannot be traveling for forever. Here, let's create a structure node. We'll do position details position, and we'll do integer distance from source, from starting point. And here this queue will be based on the nodes. Here we'll push a custom node. Distance by default is 0. Here we get a node. Here we do position. Here we do position. We do position, but here we need to create a structure. Here will be node distance from start plus 1. Very simple. Like this, chat. And so what now? Why is chat talking about Jay and Odin? If you could tell how much progress the game had been done, what would it be? I don't understand. Did we do it, chat? Yeah, we need to check for the distance as well. Here, if we are on an oak leaf and if node distance from start is less than, or if it's less than the distance limit, like this, chat. We have a limit of distance limit. We have a distance. Wait a minute, but if we reach the distance limit, yeah, it will not. Yeah, okay. We should have leave the K. Made by Jonathan Blow. Big Dave. What did we mess up? What is the problem? Image from channel. Yeah, we forgot to delete from what we had from the clouds. Let's test it out. How much time do we have? We have 1 hour and 15 minutes. Okay, do we have leave the K, chat? Okay, let's test it out, chat. Do we have leave the K? Okay, we break this block. This block. The leaves are still here. Okay, we destroyed all of the locks. Do we have leave the K? Chat, does anybody notice leave the K? Let's do a breakpoint actually. Let's do a breakpoint. Oh, instantly. And again, and again, and again, instantly. So we are hitting the code, but are we doing it for here? Oh, we need, oh, okay, I get what's the problem. We need to do position, details, set, position dirty. We need to update the subchunk. Movement is a little strange. Make it not that big of a deal. Okay, chat. Let's test it out. Do we have leave decay? Oh, a leaf got destroyed. Another one got destroyed. Chat, leave decay. It's happening. Look at this, they're dropping. Leave decay. Interesting. That's cool, chat. Yo, that's cool. Will all of the leaves get destroyed? That's what I want to know. Did it stop? Chat? Did it stop? I'm not seeing any more blocks being removed. Oh, one got removed. Interesting. Oh, another one. It should follow von Neumann neighbors instead of more neighbors. That means nothing to me. Are biomes generated or is just one biome? I had other biomes, but I removed them, chat. I had the desert, I had the snow, but I removed them because the snow had big FPS issues. And I didn't want to bother fixing it. I wanted to prioritize other features. We can come back to it to other biomes easily. We can even do biome blending at some point. Well, it kind of works. It kind of works. Yeah, most likely all of the leaves will get destroyed. Most likely. So what now, chat? I was thinking to now fix the particles. Here from our notes, in the most annoying problems section, leaves decay on trees. That's done, I think. That should be done. Done. That should be done. Item drops, we almost have them. We can fix the... yeah, some particles are grayscale. Let's fix this, chat. Let's fix the grayscale, and we'll finish the item drops as well. Because we... and yeah, to be able to pick up items. Pick up items. Be able to pick up items. Yeah, we just have these 2 leaves left from the tree we destroyed. We just have these 2 leaves. Oh, and they're gone. Done. We successfully saw leaf decay. We successfully noticed the leaf decay. That's a big W, chat. That's a big W. That's a big W, chat. So we can destroy... we can destroy all of the... when the player destroys all of the trees, they will start decaying, which is very immersive. That's cool, chat. That's cool. Nice. Okay, chat. So what now? To pick up item drops. Pick up item drops, and some particles are grayscale. And to have more particles. Increase particles count. Because currently when we destroy one block, it resets the particles from the previous block. Okay, let's do blocks pickup. And instead of regular pickup of item drops, let's just remove the item drops when they collide with the player. Let's just do that for now. Maybe we can do a function where for every entity, it has a callback when it collides with the player. What happens then? Maybe we can do something like that. Maybe. I'm not sure how to approach item drop picking because item drops are entities. Item drops are entities, and I'll have to go through all of the entities. And some of the entities could be the TNT. Other entity could be the creeper. Other entity could be the creeper. Like I'm iterating over all of these entities. I'm not sure how to actually handle it, because I will need to do a dynamic cast from the parent entity to the child item drop. I would have to do a dynamic cast. I would have to check if we manage to do it, the casting. And if we manage to do it, then I would need to calculate what's the distance from the player if it's an item drop. And if it's very close, to actually pick it up. What should be the... Okay, let's try to do the... let's see if we can do the particle coloring. Because particles for the foliage is not colored. Particles are not colored when we destroy foliage. Let's try to fix that. Why are you spamming, man? Okay, chat. How are we going to do the particles? How are we going to do the particles coloring? How are we going to do it? Okay, let's add a coloring for all of them. Let's try to change the coloring for all of them just so we can see that we can change the coloring. Just so we can see we can change the coloring. Overlay a color map over them. Use same method used to color the grass? No. Let's see what I used for the grass. For the grass, I used a texture, chat. We use a texture because Minecraft used a texture. Textures, color map. Yeah, we used color map, foliage and grass. We used this, chat. This is what I used. Foliage and grass. This is from Minecraft. The top part up here, I added this coloring. Let's ignore this part. I added that. Basically, this is the coloring for the foliage and for the grass based on the biome we're in. And I think here is the jungle. And it's based on the moisture of the biome, the temperature, something like that. So here it will be like savanna, like where it's like more dry. But here it will be like more moisture, maybe, like a jungle. I don't know. But let's see what we can reuse. Let's see where we create the particles and see if we can reuse something. And let's save our current progress. What did we do? Leaves decay. We did leaves decay. Let's do leaves decay. Okay, so now let's go to the particles. Particle positions. Yeah, here we create a particle, chat. We create a particle just using this texture ID, which we get it from here, from the mesh of the block we destroy, we get it from here. We need a color overlay as well. How do we get it? How do we get it? Where do I do the color overlay? I do it in the cube mesh template, I think, for the tint. I think, or in the cube mesh pool actually. Let's search for tint. Yeah, tint index. If the face contains a tint index. Oh no, this was no, I don't want it. This is not it. Yeah, it's here, I think. Yeah, we update the bottom color with the cube mesh pool data, tint array, and tint index. Yo, we have that's hiragana, right? How work going? Work going well, man. Work going well. That's hiragana, right? Here. And or katakana. I forgot. My weeb skills are not that great. To be katakana and kanji. Yeah. It's hard for me to differentiate. Okay, chat. Let me think about it. Yeah, where do we set this tint index? I've forgotten, chat. Cube mesh pool data. Cull sides. Data. Yeah, here we have an array and we have a maximum tints we can have, which is 10. When do we fill this up, chat? We don't use it here. Do we use the tint here? Okay, I have an idea. We'll go where? We'll go to the leaves. We'll go to the leaves. Here, generate mesh. Oh, we do it here, chat. Yeah, here we get the cube mesh pool data and we set the tint manually. Yeah, we cannot access it. We cannot access it, chat. We update the system for rendering the mesh itself. We update that and we store it there. When we create the particle, yeah, this is at runtime created, chat. The overlay is created at runtime. It's created at runtime. We need to store it, chat. We need to store it somewhere. We need to store it. We cannot store it as a block state. Not as a block state. Oh, we can just have, oh, very simple. I think we can just have two functions. Get foliage color and get grass color based on some values. Based on some values. Get foliage color map based on the biome. What does this give us? Foliage color. This is for the leaves. Let me think about it, chat. And here we give it a biome. Oh, we have an unordered map and a biome and a vector2 position. And we just use, oh yeah, we have the two functions. We have them already. We have foliage color map and we have grass color map. Interesting. Yeah, we just need to use these functions. So for the particles, when we create them, we need to check if the block is foliage or grass and to use it. That's annoying. That's annoying to do. Annoying. Can we do something else? I prefer to switch to something else, chat. Prefer to switch to something else. Leaves decay is done. Particles are grayscale. I'm not a fan of fixing this. Increase particle count. We can do this, chat. Bro, I removed the limit for non-subscribers to be able to chat. And the first comment we got after removing the limit is farting. Bro, I need to get back the chat limit. We can increase the particle count, chat. That's valid. Let me see the particle count problem. Bro, we are bringing back the chat limit. No, no, we're bringing back the chat limit. Bro, I had trust in you guys. Okay, chat. Let's look at the particle count. So here's the problem with the particle count. They instantly get restarted, chat. Let's increase the limit. Let's increase the limit. Oh, we can change chat even more. 20 minutes. Now nobody can pass the 20-minute limit. Let's see in Minecraft the particle count, chat. Let's see in Minecraft. Is there a limit to how many particles there are? Is there a limit? Or can you have infinite particles? Is there a limit? Why is there not a limit? There's no limit. Infinite particles. Why is there not a limit? Interesting. We can have a dynamic array. We can have a dynamic array then. We can have a dynamic array. Let me think about it. Because they get removed after some times. Yeah, my particles also auto remove after a few seconds. Like this, chat. My particles disappear after a few seconds. So yeah, maybe we can do something like that. Yeah, let's see how we can approach this, chat. We need to... The problem is currently I just have a static array that doesn't change the size. And I need to change it to be something else. Particle. Yeah, I have a particle positions array here. Particle positions array. Maybe it's in the header. Yeah, particle positions, and it's this size. We can do a vector. std vector of particles. Particles. And to remove these particle positions. And we'll have lots of errors. Here we need to update all of them. We'll just do for particle in particles, and we'll just do particle update, and we'll remove this. Here, here we'll just add it. Particles will push, but there is one problem, chat. The because we want to clean up particles that are yo, the farting guy is back, man. How did he come back, man? I put such drastic limits and he's back. Can we increase it more? Custom. Duration. Let's do 1 hour. You need to be, let's do 1 day. You cannot go past this, chat. This is my biggest limit I can do. You have to be 24-hour subscriber to comment. You cannot, the farting guy, yo, how are you typing, man? Okay, I'll increase it even more, chat. I'll increase it to 7 days subscriber. This is for subscribers for more than 7 days. The farting guy cannot pass this filter. Bro, how are you passing the filter? Oh no, this is 7 weeks. And it's no 7 days. Is it? Let's do 1 month. Let's do. I was going to do 1 year subscriber. Let's do 1 month subscribers. Yeah, this is 4 weeks. This is 1 month subscriber. This is 1 month subscribers. Yeah. Who has been filtered, chat? Who has been filtered? Okay, chat. Let's focus on the particles. While we have... Bro, how are you 1 month subscriber, man? How are you 1 month? 2 months. I'm doing 2 months, chat. 2 months subscribers. Let's see if the one person that 2 months subscribed. 2 months subscribers. Nobody's... Ah, we have 1 person. We have 1 person. Yo, what's up? Okay, we'll be talking to 1 person today. Okay, let's do the particles. I'll bring back at some point. I'll remove the limits. Oh, I forgot Twitch. I forgot Twitch. Twitch doesn't have limits. Ah, it's fine. Nobody is on Twitch. Okay, chat. Let's do particles. Let's focus. How much time do we have? Hopefully enough time. We have 49 minutes. Yeah, we have 49 minutes. Twitch doesn't count. Twitch doesn't have limits. It's only YouTube limits. It's only for YouTube. Oh, now everybody is on Twitch. Oh, come on. I got to go on. Oh, okay. Okay, chat. Particles. For particles, we have one big issue, chat. Since particles get removed, there is one problem. Because the left click is not on the main thread. The left click is not on the main thread. And once the life of a particle is over, it needs to remove itself, chat. It needs to remove itself, and it cannot because the vector doesn't support multi-threading. We don't use multi-threading, but the left click is a separate thread. Even if you don't have multi-threading, if we're updating the vector from the main thread and from the left click, it will break it. That's a bit of a problem. So how are we going to do it then? How are we going to do it? Oh, I have a different idea, chat. I have a different idea. We can have not one array, but multiple arrays, chat, for particles. Like we can have 10 arrays. Like we can have a buffer for... Yeah, I'm back. We can have a buffer for 10 blocks particles. We can just have a buffer. Maybe. Why did you make it 8 weeks? Chat, I'm not even sure we can increase the how many particles we have, I think. No, let's test it out. I'm back. We are waiting for him to say it. How can we push to particles here? We'll push this, chat. We'll push this. We'll push this, chat. Like that. And we need to fix one last place here. Is it? Is it here? Do we use this I anywhere else? We don't. Here, this is where we draw them, chat. The particles. This is where we draw them. So here we do const part. You can just do particle reference from particles, and we just copy paste. We just copy paste this code. And let's test it out. This should make it possible to have multiple particles. Okay, chat, let's test the particles. Oh, what happened? Wrong texture. Let's look at the call stack. What's the problem here? Yeah, this is the particle that we're using. Texture coordinates, texture offset. Oh. This is for when the particle gets destroyed, I think. Is it? Yeah, what are we doing? Where's the issue? Here is the issue. Particle texture. Oh, the texture ID is invalid. Is it? It's empty. It's empty. Let's just continue here. If particle texture ID, if it's empty, what do? We continue. And this should fix it. This should fix it. This should fix it, chat. Okay, let's test the particles. Okay. Look at this, chat. We have lots of particles. Yo, cool. But we have one big problem, chat. We have one big problem. I'm not clearing the particles. I'm just making them invisible. I'm just not drawing them when they die. I'm just not drawing them. So, like, the particles stay in. We need to clear the array. We need to clear the array, chat. That's a big problem we're having. Let me think about it, chat. How are we going to clear the array? Here, after we update them, here, we will clear them. Let me think about it. Bro, we're not adding parting, man. Chat, come on, man. Custom 1 year. Do we have? No, the channel has not been live for a year. No, 1 year is too much. Brother, how are we going to clear the particles, chat? How are we going to clear the? Oh, you're spamming, man. You're spamming. That's spam. Let me think about it. Let me think about it. How are we going to remove an item from the vector? That's what I want to see. Filter vector C++. We have how much time, chat? We have about 40 minutes. We have around 40 minutes, chat. I want to remove the particles that are no longer alive. Oh, we can create a new vector. We can delete the previous one and create a new one. We could just... Isn't there some kind of a filter function? How can we do it? Filter. What's this? Do they have an example? Okay, let's do C++ vector remove element. Remove element. Erase, I think, wants an iterator. Yeah, it wants an iterator. That's a bit of a bummer. Let me think about it. How are we going to remove particles that are no longer need? Oh, I have an idea. We will not be removing and adding them. We'll use the same strategy as before. We'll just increase the amount of particles we support. Yeah, that's a better idea. We'll just limit the amount of particles we have, like before, but we'll have a bigger limit. And this will solve it, chat. This should solve it. Yeah, this should solve it. So particles, let's change it. Let's have it be like before. Let's have it be like before. Particles, and I want that support. This is for one block. This is for one block. Will support. Will support how many? Let's do 10 blocks at most. Let's do 10 blocks. 10 blocks of particles as a limit. Let's do that, chat. Let's do that. And what then? What then next? What's next? Yeah, we update them. We don't need to remove them. We don't need to remove them. But the problem is now for the problem is now for adding particles. The problem is for adding particles because if all of the particles are static and we want to create new particles, like we will need to go through the array and find a free spot. We will need to find a free spot for the particles. That's a bit of that would be inefficient. Make the particle its own structure, its own structure, and store each one's h. I do that. I already do that. In game loop, check if its h is big enough, then remove it. When a block, I'm doing that. When a block is broken, push particles to array of all parts. Yeah, but the problem is with the removing part, chat. The removing part is the problem because it will change the vector. It will change the vector. And we are both, while we are iterating through it in the main thread, and we remove elements from the vector in the main thread, and when we click the mouse button, it will add new particles to the same vector. So from the main thread, we're removing particles, and with the mouse click, we're adding particles. Those are two separate threads, and it will be a clash. I'm not sure, chat, for the removal. Like my alternative was, instead of removing them, instead of removing them, to have an array with the same size, to have an array of particles that doesn't change its size. That was my alternative. But the problem with this approach is that when we add a new particle, we don't have a specific spot for it. That's my problem. So I would have to do for each particle, where when we break a block, it's like how many particles when we break a block? It's 4 by 4 by 4. It's 64 particles. So when we break a block 64 times, we will be looking through the array for a free spot for the new particle. And that's extremely inefficient, chat. Vector arrays needs an iterator. Vector arrays needs an iterator. Oh, yeah, okay, let's do this. Okay, we'll bring back the previous. Okay, we'll use a vector. Yeah, okay, I have an idea. Yeah, we'll try this, chat. We'll try particles here. We'll do for auto iterator equals particles begin, and we'll do while iterator different than particles end, and here we'll check the lifetime of the particle. Yeah, lifetime. What's the update do? Yeah, if lifetime is less than equal than 0. Here, if the lifetime is less than or equal than 0, we'll do iterator equals particles arrays, the iterator. Else we do iterator plus. Let's test this, chat. Let's see if this works. Let's test it out, chat. Hopefully. Okay. It seems to be working, chat. Okay, we have infinite particles, I think. Let's test how much the size of the particle array is. Let's do a breakpoint, just to be sure if we're actually erasing them. Yeah, look at this, chat. If I do a breakpoint here, which iterates over all of the particles, it doesn't do it. Like it has no particles to iterate through, so it's actually working. So it's actually working, chat. So for ideas that are done, Increase particles count is done. This is done, chat. This is done. What's next that we can do, chat? What's next that we can do? Some particles are grayscale. We attempted that, but it's difficult to get the color. It's difficult to get the... We could do an attempt. Item drops to pick up items. That would be useful. And to be able to throw items from the inventory. That would be useful as well. Item picking. Pick up items. Yeah. How much time do we have? We have 30 minutes, chat. We have 30 minutes. Bro, look at this, man. How many particles. This is sick, man. Okay, let's fix the grayscale bug. I think it should be very simple. Should be very simple, even if it's not perfect. At least to not be grayscale. Let's do that. At least to not be grayscale. Some kind of solution. Let's do some kind of solution. Like at least to do it for the leaves and for the short grass. That's what I want. For the oak leaves and the short grass. This is this should be good enough for now. But let's save the current progress. Let's save the current progress. What did we do? Infinite particles support. We are supporting infinite particles. So what did we decide to do next? Bro, a lot of people will not be coming back. What were we going to do? I forgot. Grayscale. Particle to not be grayscale. Where did we handle the coloring of particles? Let's try to find the particle entity. Particle entity here, but we don't draw it here. We draw it in the game itself. Draw. Drawing. Particles. Yeah, here. Here is where we draw them. The particles. This is where we draw them. Yeah, we draw a billboard at this position. Yeah, here. Yeah, here. Let's change this to red. The overlay. Let's have a color overlay. Don't worry, chat. They will not be coming back. I can promise you that they're not coming back. Okay, chat. We colored particles to be red, chat. We colored particles red. We have red particles, chat. So let's get some kind of a foliage color. We'll just reuse it for the leaf. What we do for the leaves and what we do for the yeah, just the leaves and the short grass. But how are we going to check the block ID? Because the particle itself, let me check the particle itself. It has the texture ID. It's a bit of a bummer. We could save What data can we save? Should we save? The ID of the block that created the particle, or should we just save a color overlay here? If it has a tint. If it has a tint, this comes from the mesh itself. That's from the mesh, chat. That's from the mesh. Let me think about it, chat. I want to check just the ID. I just want to check the ID. If it's the oak leaves and the short grass, that's what I want. Nothing complicated. And maybe we can even just do it with the texture. Okay, let's say for the particle ID, block ID, or just ID. And when we create it, what's the issue here? No issue, absolutely no issue. When we create the particle, yeah, here, when we create it, tint seems more general. You won't have to update the ID later. Yeah, but the tint comes from the mesh itself, chat. The tint. Okay, let's look at the mesh for the leaves. For the leaves, oak leaves. Here, leaves. Here. Oak leaves. Look at this, chat. This is the problem. If we look at the tint from the mesh, the problem is the mesh has parenting system like this, chat. So I would have to check the mesh here, and okay, it has a parent. We need to go back to the parent, which is the leaves. Okay, we go to the leaves, and here we need to go to the mesh itself. We need to go through all of the cubes, and from all of the cubes we need to go over all of the faces, and inside of the faces here we need to check if it has a tint index. That's a bad approach. I don't want it will be the proper approach for the future. For now, I just want to check if it's the leaves or if it's the foliage, or if it's the short grass. That's what I want. Improvements we'll do in the future. It's fine, chat. It's fine. We'll do improvements in the future. Bro, how did you add glasses to the emoji? Let me think about it. Yeah, the particle constructor here will just save an ID. Very simple. And the particle constructor here, ID equals ID. ID, like this, chat. And here the default ID, let's say it's air or invalid ID, like this, chat. And what now? And now we need to give the ID when we create the particle. Here we want to give it maybe the block hover ID, because that's the block we destroyed. Yeah. And now when we draw the particle, here we draw it. Here is the overlay, color overlay. We want to do if particle ID, if the particle ID equals oak leaves, else if particle ID equals short grass. We'll be covering just two options. Just two options for now. For the leaves, and let's have here the color overlay. color overlay. It's 1, 2, 3, 4 values. Here, let's do color over tint. We can just call it tint, and by default it's white. By default it's white. But if it's the oak leaves, we'll do the same coloring we do for the leaves. Same coloring we do for the leaves. Yeah, here, this. Yeah, is this. Let's go back. Here. Tint equals like this. And here we want a biome. Biome is, oh, we give it here. It's a bit of a problem. That's a bit of a problem. Let's do by default the planes. Let's do by default the planes. And let's do the same for the grass. But for the grass, no, for the leaves, no, for the, what was it, chat? We had foliage, color map, and grass. Yeah, and grass. Oh, so it's just foliage then. It's just foliage. Okay, so we can do here, or if it equals short grass, and we'll remove this, and we'll use the foliage, and here we'll use the tint. Okay, this should do it. This should be good enough temporary approach. I like working on something and like listening to you while doing that. That was my goal for this stream, to help you guys focus and to help me focus. That was the goal of these streams, chat. Oh, yo. Particles has coloring. Yo. Finally, man, it has coloring. Finally. And the grass has coloring. How much time do we have? We have 18 minutes. We have 18 minutes, chat. Can we do item pickup in 18 minutes? Can we lock in and do it in 18 minutes? Why has grass tone sound? Because we didn't have time to do other sound. When are you going to work on item pickup? Okay, chat. So we have, we don't have grayscale particles. That's done. That's done. What's next? Pickup items. Let's do something simpler. Let's just delete the item when we collide with it. When we collide with an item, to item drop to delete it. Let's just do that. That would be simpler. Oh yeah, and to decay the grass, like to remove the grass when we destroy block here. We can do that as well. Destroy grass when block break. At this point, can't tell if this is your clone or Minecraft. No, it's my clone. Okay, let's do item pickup, chat. How are we going to do item pickup? Do we iterate over all of the item drops, or do we like iterate over all of the item drops and compare the distance with the player, or do we from the player? It will be the same thing. Actually, we don't have alternatives. It will be the same. We don't have alternatives. We'll iterate over all of the item drops in some way. We'll iterate over them in some way. Okay, let's iterate over all of the entities, but let's save the current progress. Let's save the progress. How? Here. Particles have foliage coloring. Nice. This was a good addition. Let me think about it. What were we doing? Picking up items. We need to iterate over all of the entities. Let's do it in the on update chat. Let's do it in the on update. On update here. And at the end, we'll iterate over the... When are we going to do it, chat, actually? Entity. When do we actually do this? Do we have update here? Yes. And here we update all of the entities. Oh, I have an idea. We'll do it in the item drop itself. We'll calculate the distance from the player. And we'll do it maybe... Should we do it every tick or every frame? Every tick or every frame to do this calculation, because to calculate the distance between an item drop and the player, we need to use square root. We need to use square root, which is inefficient. Every tick. We can try every tick. We can try. Okay, let's try every tick and see what happens. What do we have in the item drop? Yeah, we have on tick update. Here, we'll check the distance between us and the player. Let's check the distance. Let's do vector 3 length between vector 3 subtract the position and the player. World player. I have get player camera. Okay, let's do get player camera. Position. Okay, we check the length. If the length is less than 0.5, to remove it. Bro, where am I typing this? If like this. If it's like this, we'll just do the... What do you call it? Yeah, let's have the item drops have... Oh, they should have a lifespan as well, right, chat? Do item drops have a lifespan? Let's add it a lifespan. Int lifespan. And how many ticks should an item drop survive? 5 minutes? 5 minutes. Okay, 5. So 5 minutes times 60. This is 300 seconds. And so Sparta. 300 seconds times 20. This is 6,000 ticks, chat. 6,000 ticks. 6,000 ticks. So here let's do lifespan equals 6,000, but if it collides with the player, we'll shorten the lifespan to 0. We'll shorten it to 0 if it's colliding with, if it's close to the player. We don't even need to worry about collision. If it's just close to the player, we'll set the lifespan be 0. Chat, are you hearing that? Chat, you hearing? Bro, they're like super close, man. Do you hear something? Bro, that's wild. Okay. I'm back, chat. Let's use the actual lifespan, chat. Let's use the lifespan. Let's use the lifespan and let's do something similar like we did with the particles. Particles. Lifespan. Lifespan. Particles. Yeah, here. Oh, lifetime, brother. Lifetime. Rename. Lifetime. Lifetime. Game layer here. I want to do something similar. Something similar for the entities, chat. Something similar. Inside of the world. Update. Oh, I had a should delete. Oh. I have a should delete for entities. And I'm not using should delete. Brother. If lifetime is less than or equal than 0, lifetime minus minus, and here we do should delete equals true. Should delete equals true, and that should solve it. Damn it. So what now? What now, chat? I think this is it. Yeah, we should have item pickup. It's not working. Why? Item drops should be as entities, right? Let's test if we let's do a breakpoint there. Let's do a breakpoint. Let's do a breakpoint. Oh, it's not activating the. Oh, maybe this code is not executing. Let's move the breakpoint. Okay, it's executing. Oh, so then the length is not less than. Oh, so because the camera is way higher up. Damn. The camera is too high for it to be less than 0.5. Then what, chat? Then what? Can we just get the player position? I think we can, but it will be annoying. Let's do 1. Let's do 1. To get the player, I will need to get the game layer. And I don't want to be getting the game layer. I just want to use this world singleton. Okay, let's do distance of 5. Let's do distance of 5. Oh, too much, too much. Okay, let's do distance of 2. Let's do distance of 2. Do distance of 2. Okay. I think too much maybe. Oh, I have an idea. No. I have an idea. We'll just make the item go towards the player instead. And when the distance becomes very close, we just delete it. Let's have the items go towards the player instead currently. How are we going to do that? We need a direction. We need vector 3 direction equals, and we'll use this subtraction. Here, this points towards our current position. We don't want that. We want to point towards the camera, and I want vector 3 normalize. I want to normalize it. And so let's do velocity equals the direction. Let's just make it equal the direction, no matter the distance. Then we'll do a limit for the distance. Look at this, it's going towards the player camera. Let's increase the speed by 2. And let's make it be let's change it up a bit. Normalized direction. And here, because we need the difference. No, we do direction, and here we do difference. Here we do the difference. This is the direction. Because I want to do, and here let's do flow distance equals vector 3 length of the difference. I want the length, chat. Oh, but here I'm getting the length I'm getting the length 2 times. Let's just get it once, the distance here, and we'll normalize it ourselves, chat. We'll normalize it ourselves. Okay, I don't care about optimization. Make a direction radius and destroy radius. No, it's fine, chat, it's fine. And we do if distance, if it's less than 2, we update the velocity like this. We update the velocity. Yeah, let's test it like this. And else, if distance is less than 0.5f, we pick it up. So lifetime equals 0. Let's do something like that. Let's test it out. Not working. Oh, working. Bro, why are you not getting deleted, man? Oh, distance cannot be less than 0.5. Oh yeah, you're right. I'm just dumb. Chat. Thank you. It's a bit weird, chat. No. That's not how Minecraft does it. Survival. Yeah, it comes up at a bit lower location. Oh, I can offset it. I can offset it. To not go towards the face, but lower down. Yeah, let's offset the camera position. Camera position, let's do minus vector 3 0 1 0, like this, chat. Let's do it like that. Maybe a bit higher up. 0.8. And let's make it faster. Let's make it be 4 times. Speed of 4. Is it getting bigger? I'm not sure. It's just getting closer to the camera. That's just like perspective. Maybe we need to... Chat, what do you think of the speed? Do I need to increase the speed of the pickup, chat? Oh yeah. Let's increase the speed. Let's do 8. Let's double the speed. Oh, a sound, to add a sound. Yo, we're picking up items, man. Too fast? That's not that big of a deal. Not that big of a deal. Okay, let's add a sound. That will be important. Item pickup sound. Minecraft item pickup sound. Wiki. Item sounds. How can I find the pickup sound, chat? They call it pop. Isn't you break a block while you're inside it, but still sits on ground? Not to. What's this? Item frame sounds. Friendly mobs. When an item is placed in an item frame. Bro, where is item pickup sound? Minecraft pickup sound. Wiki. I cannot find it. Not that big of a deal. In Minecraft assets. Okay, chat. What did we do today? Minecraft assets. It's fine, chat. It's fine. Don't worry about it. What did we do? The first hour of the stream, we attempted to add 3D clouds. We spent brainstorming the whole hour, but we didn't. We found a problem where it turns out geometry shaders are not supported, sadly. Godot, Raylib, all of them avoid geometry shaders because they have their reasons. Like it's like they're going to be deprecated. So I wanted to have 3D clouds using geometry shaders, but they're deprecated in the libraries and engines. So we switched. We switched to what, chat? What did we accomplish? Where's the notepad? Here. Leaf decay on trees. So when we break the oak, now these leaves actually decay. Look at this, chat. Leaves decay. And after some time, like maybe 5 minutes, all of this will decay. Okay, this here, this is missing, this is missing, this block is missing, up above, blocks are missing. And we saw for one tree, the whole leaves disappeared. Like you can go back in the stream, you'll see for the whole tree, all of the leaves disappeared. It just took a little bit of time. Maybe we need to increase the speed, maybe. But we did the leaf decay. We increased the particle count. So before, once you destroy one block and you immediately destroy another one, it replaced the previous particles. There was a limit to how many particles there are, but now particles are unlimited. So if we destroy lots of blocks, we'll have lots of particles. Particles are not limited. The other thing we added is item pickup. Okay, how items go towards the player once you get close. We have item pickup. We attempted to find the item pickup sound. We couldn't find it, but chat is saying it's in the UI sounds category. Let me look it up. UI sounds. I don't see UI sounds. Minecraft UI sounds wiki. Or you're telling in the assets. Out. Oh, this. Is it this? A bit different sound. We can use it. We can use it. Should I add it? If I add it, it will take some time because I will need to copy paste this sound multiple times. No, we don't have the time for that. We're over the time limit. But thank you, man. We'll use it for sure. But yeah, we have item pickup, chat. Okay, how items go towards the user. That's pretty cool, chat. Item pickup. That's pretty cool, chat. And so tomorrow is Saturday, and then after that is Sunday. Usually I don't stream Saturday and Sunday. So most likely next stream will be Monday, chat. Just so you know. Most likely next stream is Monday. Oh yeah, I forgot about this. The particle coloring. Look at for the leaves. Before it was grayscale, but now look at how it's green color. I'm very happy for this change. Very happy for this. Now it's green color. I forgot about that. And also here, the grass. Okay, how is green color. That's cool, chat. So that's it, chat. That's it. We'll see each other most likely on Monday. Most likely. We'll see. Too saturated. That doesn't matter. We can always change it. Yeah, bye guys.